All right, what we're doing today is we're going to go over the final from May of this year. This afternoon, we're going to go over the one from June of this year. On Thursday, we'll go over 2 more finals. Well, let me write that down. The 4 p.m. is June 16. Thursday, we'll go over another final. So in the end, we'll have 4 sets of finals that we can review, just go over. Friday, the tutorial is actually going to be our Friday tutorial is actually going to be the final review. And that's from 1 to 3, and it is in Bishop's Hall. For those of you who may have remembered the last tutorial, there was a group of kids trying to have lunch in there. We will not allow it this time. We've reserved the place, it's ours. We're no longer gonna be nice because this is the final review. So kick them out. Even the little kid in the wheelchair who was, I felt bad about.
The finals were going over Thursday and weren't on Blackboard yet?
No, they're not. Between now and then, I'll put them up. Let me think. So let's just briefly talk about where we are and where we're going and where we plan to be. So we've had the homework, which is 10%. I've got one grader who still hasn't finished the last 2 problem sets. She's currently getting it done. It will be done shortly because I'm getting daily reports. Test 1, test 2, test 3 are now done. 15, 20, and 25%. Right now, for the homework, I've kind of decided, well, right now, let's just go one at a time, Vance. The homework on the syllabus, I based it on a 0 to 10 point scale. I've changed it to a 2 to 12 point scale, and it's still out of 10 points. This is the lost homework. I promise you, I turned it in homework. This is the combined with my grader was a complete and utter jerk for most of the semester, all that stuff. So that lifts probably 20% of the class into having a score of 10 or higher, so that they get effectively bonus. And it brings up the people who may have missed a homework or lost a homework or something like that.
Is that in the book or on Blackboard?
Is that, that will be in the book. That will occur after the final. So what you have in your, on your Blackboard score is your cumulative raw up to this point. And so you could write a little spreadsheet that says like So this is the equation used, just raw score, to calculate your final cumulative grade. Your homework score divided by the maximum homework score of 66 plus 10. Now, right now, what I end up doing is I just go plus 2 to affect that. So that's 2 full percentage points on your final grade. 15% times your test 1 divided by 100, 20 times test 2 divided by 100, 25 times test 3 divided by 100. Notice this, 30, final grade is 30%, so it's 30 times final score divided by 200. So the final is out of 200 points. That's because effectively the final, when compared with the test, is twice as big. So let's just go over the general layout. So a test is 1 hour and 15 minutes. It has 25 multiple choice, 2 appetizer, or not 2, 1 appetizer and 3 problems. The final is 3 hours. So more than twice. So if you doubled it and then tacked on an extra half hour, that's the length of the final. I go 50 multiple choice, 2 appetizers, and 6 problems. So it's effectively doubled, but you get a little bit more when with respect to time. For those of you in SDS, most likely what will happen is I will proctor the main group, and we'll do like we did before. The SDS students just meet me shortly before the final outside my office, and then we'll go from there. All right. Next, 100 points, 200 points. So when we go over this test, you'll be able to see a lot of the differences and what types of problems. And probably on the final review, we'll go over more specifics about what the test is. Safe bet problems. Vector addition. You're going to get a vector addition problem. Why? Because you're Eschenberg students. We always do vector addition. Second, 2D motion. There will be a 2D motion problem. What type? Could be any type. Rotation, alpha equaling 0. We did alpha equal non-zero on the test, so we're going to do something with 0 on the test. Atwood's machine. Motion or energy. And already we're pretty much filling up our 6 potential problems. And then there will be something, since we did not do it on a test, an inelastic collision. And so we'll have something like that. As for the 6 problem, I'm not sure yet. Haven't even written it yet. I'll probably write it over the weekend. And then the 2 appetizer problems, I don't know.
So the vector addition will not be an appetizer, it will be
It will be a straight up, yeah, it's going to be that's a good point. There have been Are you asking that question because you've read one of the finals? There was a final where I did an appetizer for a vector addition, and it was just basically to, like, given this vector, change it from polar to component or something, where it was a lot more simple. It depends on my mood. The thing is, with 6 problems, and I got to cover an entire semester of physics, I got to hit the major keys. And if I think I need to have a 6th problem, I may bump the vector addition into an appetizer. If you could do a vector addition problem, the appetizer vector problem won't be, or vector appetizer won't be an issue at all. All right, let's take a look at the test, because there's something that we have to share. We have to share for a moment. I really need to get a copy of the first final, because the first final is basically like just that first bullet. You sit there and you read it, and that's it. Read the final. I appreciate good penmanship. I'm not a psychic. Show all work. Answers judged as unreadable or confusing will not receive points. No notes or books. Closed book. No books near you. You're allowed to bring pens, markers, crayons, erasers, rulers, protractor, and your calculator. I appreciate color. I appreciate highlighted answers. We're playing by MCAT rules, so if you put the right answer on your test, but the wrong answer on the Scantron, points will be taken off. Yes?
So will it be in the regular when we take a
Oh, physically, actually, 1 week from today, right now, you'll be taking your final right here. So it's a Tuesday, whatever day that is, 8 a.m. to 11. Now, a couple of things about that test. Because you have the 8 a.m. slot, there have been occasions where the organic chemistry professor who has his final at noon demands that I move my final. According to the rules of the University of Mississippi, if you have 3 finals on that day, it's the responsibility and obligation of the noon final to move. He has to make other considerations. So for me, that final is happening at 8 a.m. regardless of what that chemistry professor thinks. So.
All the organic sections are Monday, Wednesday, Friday this year.
Okay, whatever. But then that just means that the Wednesday final from 4 to 7, they won't move. I don't know when they are. I mean, it's really, I sleep so well because I sleep on a bed of organic chemistry texts. Because I like sleeping on things that are soft. You can tell them that. It worked a lot better last year. God, you guys aren't funny at all. Maybe the delivery wasn't right. All right. Huh? All right. No snark answers. Okay, if I'm going to have the right date, if you miss the final, if you miss it for some valid reason, like you're dead, if you miss that final for a very valid reason, you will be allowed to retake that final in February. So, don't miss the final. You've got to take the final. If you miss the final because you broke your leg, fine. We'll make do. We'll keep you in 214 in the spring if you need it, but you're going to take that 213 final in February. That's an incentive for you to take the final, because if I have 20, 30 people moving their finals around for various reasons, oh, I need to take my final on the last day of finals week. I've got a final on Tuesday, I got a final on Wednesday, and then I have 323 class grades and 420 lab grades to lock into my Ole Miss by the following Monday. And if I'm proctoring finals for the rest of the week, you're effectively destroying my ability to grade. Now for this. This is the layout of the final. And this is how I deal with a particular problem known as my students. For the first couple of years, I would always get this after the final. Dr. Eschenberg, I tried real hard. Dr. Eschenberg, is there anything else I can do? I get that all day long. And what happens is, it disrupts my ability to grade the final. It ruins my ability to grade grade the final, and it damages my calm. So, when you get done with the final, you may go over to Lewis Hall for 1 hour. Preferably never enter that room again. If I see you outside Lewis Hall after that hour, I'll give you the politest of nods and I'll continue on. But if I find you, see you, sense you, or twitch because you are inside, outside, above, below, looking at me through my window in my office, looking at my window when I'm not in my office, using any bathroom in Lewis Hall, you are free to use the bathrooms of Martindale, Brevard, Turner, and the Lyceum, but don't leave your biological waste in Lewis. How do I know when my students are using the women's restroom? I will only say that it is respectful, within the boundaries of the law, and effective. And or in any place, this includes, well, that's the last lab physicist. You can't even go into Dan's office. Location, time, space, alternate universe, astral projection, or dimension I deem inappropriate, you will suffer the consequences. The consequence for violating this rule is simple. I will deduct 200 points from your final. Simple. Simple price. To come by my office and do that, that's 200 points. And yes, you can get a negative score because of this. The best way, the only way you can help me grade is to leave me alone. The full strength of Dr. Eschenberg is going to focus, ponder, and assign grades fairly. I will be extremely busy during this time. If you knock on my door or do think or insert anything I decide to enter at a later date, time, or insert anything else I can think of, seriously, am I getting through to you yet that disturbs my calm? You are hurting yourself, the class, the planet, the universe, and all of history. Cheers, Dr. Eschenberg. What this means is I've got to have privacy. The best thing for me to grade your final fairly, to grade your final grade for the semester fairly, is to just leave me alone. I'm under a lot of pressure up until that Monday that we turn in grades. This is effective until, well, generally in the spring, it's effective until the National Football Championships have been decided. After that, you can email me and then we can talk about it. Grades can be changed easily for up to a year. So if you honestly think that your grade was wrong, talk to me in January. Don't come by my office right after finals. So, and if you're thinking to yourself, well, this rule doesn't apply to me, it applies to you first. Are we clear? Do we understand? All right, everybody's just sitting there going, well, he's just done. All right. He's falling off the rocker. All right, what we're gonna do is we're going to do one of the multiple choice, just run through it. I'll go back and do the other two versions, and I'll post that. Question close on the left. Am I going to add any what? Add any points to the test? Oh, if I find an error, like let's say, like for Liza, like after, let me tell you the worst thing for, I ever did in response. There was a torque bar problem, and I had people coming up to me saying it's impossible. And I was repeatedly saying it's a correctly constructed problem. And interestingly enough, Dan Miller, your lab physicist, was one of my students, and he came up to me and goes, "Dude, this isn't working. It is impossible." And I was like, "No, it's a correctly constructed problem." And then I started grading finals, and I went, "Whoops." So what did I do? I failed everybody. No, I gave everybody full credit for the whole thing. So it's when mistakes are made, and I've legitimately found them. Typically for multiple choice on a test, I only go through them. For a multiple choice on a final, I get me and one of the other graders to prove it. So we get multiple options. Does that answer the question? A curve on the final?
No, on like test 3.
On test 3? Right now, no. But I reserve the right at a later date to curve. Test 3 for the afternoon? No. They're not getting anything. Their grade was a little bit higher. I still have to figure out why. What's really weird is the bucket and Liza averages for the morning and the afternoon matched. But the whole version for the morning was lower, and the whole version for the afternoon was higher. And I gotta figure out why. It was a weird thing. But overall, I think it was fairly graded. But curves may happen. Yes.
Did you mean the whole for the morning was lower than the other two, the average?
Was it lower than the other two?
Like the whole average lower than?
I need to get those numbers. I have the numbers up on my wall. I'll post them. I'll send them out. We can all look at it. There was another. Were you the second question? There was another question right in. I thought. Oh well. It's another reason why I don't want people to come by my office, because when all the grades are done, and I've got all the numbers, they sit on my spreadsheet, and then from Friday through Monday, I just sit and stare, and then I have like little curve knobs that I just set the numbers. And yes, the labs will be curved, to answer that for the 15,000. JB's or John Brock's lab was low. BB's lab was real low. But oddly enough, BB got among the best reviews. You loved for him to fail you. It was very odd. In the back. Will the curves what?
What do you think the curve is going to be on those 2 lines?
I don't know. It's going to be a comparison of how you all do with respect to each other within your own lab, and then how each lab does with respect to everybody else. As an example, there was a lab, I mean, you want to just stab them with grades. Their average was a 92. So the person with an 89 didn't get curved. There was a lab that was an 86 at one point. 86 is about right. A BB plus average for a lab is what I'm looking for. If the average, just real quick, something under your desk is blinking. Like there's your phone. And I'm seeing it and it's bothering me. Okay, better. if your average was a 77, oh yeah, that's a good curve. That's just gonna slide up. Because TAs can't grade consistently amongst each other. I had a TA whose nickname was Bloodbath McGrath. He got curved a lot. So it's all sort of, he doesn't TA anymore. He's in Kentucky. We got rid of him. But for BB's probably going to see the biggest curve. John Rock, not so much. My lab, I haven't looked over, I've got everything graded in my labs. They haven't been posted yet, but when they post, I'll have an idea how much I'm going to curve.
Will Shabana's?
Huh?
Will Shabana's see a curve?
Probably. If her average is 86 or above, no. If her average is 86 or below, yes. I try to get all the labs' averages curved up to about an 86. Yes?
Do we get to choose our TA next semester by chance?
You can. It's a very unique situation. This is the first semester where we've actually been informed of our list of TAs. Dan and I are both TAing again. Michael is TAing the Wednesday night. I think Dan is TAing Tuesday. I'm TAing the 5 and 7 on Thursday. So if you want to make a change, just come up to me. There have been 2 drops from spring 214, and they were all claimed within half an hour. So I expect between now and the first week of class, 2 or 3 tops. It rarely happens. The big dump will happen the first Tuesday of the first week. That's because this room's going to have 250 students in it, and there are going to be people whose high school classes were only 12 students big, and they're going to freak out and drop the course once the class ends. So you can figure that out. All right. Bored? If I answered all, you are bored? Okay, that's good. Honestly, I like that. Yes.
We don't have to come Wednesday or lab, do we?
There is no lab this week, so don't go to lab. The only people who go to lab are, there's a select number of makeup labs that Dan has approved. So there's nothing. I won't be there. So that's a fair enough answer. All right, anything else? Okay. No new material. It's all review. Let's just rip through one of these multiple choice real quick. Units of energy are joule. Displacement over time. Average velocity. If it was distance over time, average speed. Radial acceleration is what? V squared over R. Let me blow this up.
Are you going to do like you did for the last semester, put all of the multiple choice answers up there?
Yes. And you can notice a lot of similarities. Radial acceleration is what? Awesome? It is awesome. Best selection. Points towards the center. Convert 2 nanometers into meters. B. And I will definitely say that know your units. Know all the units. I'm really asking between 10 to the negative 9 through 10 to the 9 in steps of 3. So negative 6, negative 3, positive 6, and positive 3. Know all the big ones. You won't have to know furlongs. You won't have to know fortnights. You put your thumb over the opening of a garden hose, water velocity increases. A simple pendulum is mass independent. I'm gonna have to play with this a little bit because if you know anything about multiple choice, you look at those two and go, well, those are contradictory. It's gotta be one or the other. Resonating half pipe, the third harmonic is the same as the what? First overtone. So in the overtone, fundamental frequency, first overtone, second overtone, third overtone. Harmonics, first, third, fifth, seventh. You are 10 meters underwater. The total pressure on your body is 2. What else are you, what are the 2 sources of pressure for that? Pressure of the air and pressure of the water, yes. Rotational equilibrium, some of the torques. All right, speedometer measures instantaneous speed. And every year I get the same thing, but I've never driven a car. Figure out what an odometer and a speedometer do before you take the test. If your acceleration vector is in the opposite direction of your velocity vector, you will what? You will slow down. What are the units of linear momentum? The what? Kilograms meters per second. Which is a valid fourth quadrant vector? It's B. Fourth quadrant has positive X and negative Y. A rocket spins a disk from rest. Which value is constant? D, alpha. If that rocket is spinning up a disk from rest, its frequency is going to change, its angular velocity is going to change, its period is going to change, but its angular acceleration will remain constant. What are the units of coefficient of friction? None. Are actually blank. Pressure is A, force over area. What is the inverse of frequency? Period, yes. Uh, 19, irrelevant. Probably cover that next semester. It's constructive, yes, but it won't be on the test. We're familiar with, did we? I may have, for all these strings, probably what I did is I wrote them up on the front of the, we'll do the standard 1, 2, 3, 4, and 5. Which has only 2 nodes? 1. Object neutrally buoyant. A. Object slides across the floor which is not used. E. Static friction. If it's moving, static friction isn't used. If it isn't moving, kinetic friction isn't being used. 2 strings of our identical length, material, and tension both resonate at its first harmonic. String is thick, other is thin. The thicker string, lower frequency. But the thicker string also has a higher mass density. You convert square meters to square centimeters. Multiply by what?
Wait, what? With the mass density?
Has a greater mass density, thicker, more mass per unit length. If you've got that string and you've got that string, there's more mass there than there is there. Convert square meters to square centimeters. Multiply by what? 10 to the 4th. Because that's 100 squared. Work has what units? Not Newton, joules. String 2 is vibrating at what? There we go. B, second harmonic. Which is not a proper expression for the units of acceleration? A. Units of moment of inertia are A. The relationship between normal force and kinetic friction force is yes, C. You could look at this. Is friction force parallel to normal force? No. I don't know what that means. It's definitely not none of the above. And that's nonsensical. An Atwood's machine has no friction. Yay, no friction. What is the ratio of E start over E end? D, 1. It would also be the same as E end over E start. Those things would be the same. If there was friction, let's say there was friction for a moment, what would be an acceptable answer for E end over E start if there was friction? It would be less than 1 because E end would be less than E start. So it could be either B or E. If there was friction, what would this ratio be? E start over E end. Greater than 1, so 5. For a string, the first overtone is the same as second harmonic. Fuchs law and vector notation. E. All right. Bo Wallace throws a football to Coach Freeze. Which of the following values is 0 at the highest point? Threw it the wrong way. At the highest point, which of these are 0? B, vertical velocity. You bob up and down, and we're starting to see the similarities. If you remember all the multiple choice tests, I mean, stuff's coming back. Bob up and down 20 cycles in 10 seconds in a wave pool. Your period is what? C. -2 x hat meters is what in polar notation? B, 2 meters at 180. You measure the period of the spring pendulum, it's 3 seconds. You increase the mass at the end of the spring. Its new period can be what? 4. Spring pendulums are mass dependent. Increase the mass at the spring, period is 2 pi square root m over k. Increase m, period goes up. Units of radial acceleration, A sub r, are D. if I was asking for those units, what variable would I be looking for? Angular acceleration. What's another way of expressing angular acceleration? Alpha. Good. So radial acceleration is v squared over r. Units of velocity are in meters per second. R is in meters. That gives you meters per second squared. One of my more favorite questions, 38. Units of coefficient of friction are? It's E. A Newton is a kilogram meter per second per second. Newtons divided by newtons is nothing. Nothing are the units of coefficient of friction. Unit for frequency is hertz. How many antinodes are on string 2? Antinodes on string 2. 2. Thread is being pulled off a spool. Spool revolves at a constant rate. Which of the following is false? It's C. If that thing's rotating, it has a radial acceleration. Units of angular acceleration we've just talked about. Object is negatively buoyant. I'm going to speed up because I want to do problems. Lambda is mass per unit length. Normal force is always blank to friction force, perpendicular. Bo Wallace throws football to Coach Freeze. It's valid velocity vector at its highest point. It's all going to be an X. Atwood's machine has friction. That ratio has to be greater than 1. Frequency observer moving towards a source. Translational equilibrium. Velocity of sound in a vibrating string. And that is it for the multiple choice. All right, what I'm going to do else is do the other versions outside of class. And let's just rock away on the problems. All right, appetizer 1. And if we don't get done with this, most likely what will happen is on Thursday, we'll finish this final, but not do the multiple choice of the next final. I'll just do it beforehand. And if you have any specific questions, we can talk about it. Also, this killed a lot of time. Appetizer, Bernoulli's equation and equation of continuity. A1, V1, A2, V2. We need to find V2 first. It's circular at both ends. So pi r1 squared V1 is pi r2 squared V2. Pi's cancel. R1 squared V1 over R2 squared is V2. R1 is the top, 3 squared. I'm not concerned about units because those are the same units and they cancel. V1 is 10. So 90 divided by 16, 5.625. Now for the next part, finding pressure, P1 plus rho GH1 plus 1/2 rho V1 squared equals P2. Do I have to what?
Those are in centimeters.
Yes, but 10 is in meters per second.
Okay.
This produces centimeters squared, that produces centimeters squared. Cancel. Yes.
Can you hammer out some of the problem?
Okay. And so we have Bernoulli's equation. You'll always treat the bottom as having the lowest h. So this particular h is 20. I want the answer in atmospheres. So P1 plus rho GH1 plus 1/2 rho V1 squared minus 1/2 rho V2 squared, and all three terms here, not this, 1.013 times 10 to the 5th. These will be producing newtons per meter squared. That converts it into atmospheres. So this gives me 1,000, 10, 20, plus 1/2, 1,000, V1, 10 squared, minus 1/2, 1,000, 5.625 squared, all divided by 1.013 times 10 to the 5th. Calculator people, what did you get? Oh, now you're grabbing for your calculator. This is... I get 4.3 atmospheres. So that's the first atmosphere, or first appetizer, excuse me. For the next problem, we have a simple torque bar problem where I only need this value of T. It's in rotational equilibrium. Probably the best point to pick would be that. The three forces, I'm going to call R1, R2, R3. M1GR1, M2GR2, and TR3. Now, to do the right-hand rule, that's to the left down positive, that's to the right down in negative, that's to the right up positive. I'm looking for T only, M2GR2 minus M1GR1, TR3, M2GR2 minus M1GR1 divided by R3. And that's the tension. So this is 5 times 10 times 2 minus 1 times 10 times 1 divided by 3. $90 divided by 3 is 30 newtons. I couldn't get the atmospheres to work out perfectly, so I ended up making the other one work out right. All right. So now we're down to 6 problems. Atwood's machine for problem 1. Giving me a ratio of units. I'm looking for V, final velocity. I'm only using the equations of energy. So energy initial minus the energy released through friction is energy final. The energy initial is only potential energy, so this is M2GL. Now the work done, sum of the forces vertically is 0. 0 is normal force minus mg. Normal force is equal to mg. Friction force is mu sub k. mg, the work released through friction, is mu sub k mgl. Because work is the force times the distance. So this is mu sub k m1 GL. Energy final is just the kinetic energy of both objects moving together, 1/2 m1 plus m2 v squared. We got to find v squared. The difficulty lies in the fact that the masses are not given, except that m1 is equal to 1/5 m2. And that's what we're going to take advantage of. You could do it either way. 5m1 is equal to m2. Why not? 5m1 GL minus mu sub k m1 GL equals 1/2 m1 plus 5m1 v squared. I'm going to factor out an m1, a g, and an l out of the front row. m1 gl. So 5 minus mu sub k. m1 plus 5m1 is 6. 6m1 over 2 is 3. So this is 3m1 v squared. M1's cancel, so I'm left with GL 5 minus mu sub k divided by 3 is equal to v squared. Square root GL 5 minus mu sub k over 3 is equal to v. Plug in numbers. 10. L is 20. 5 minus mu sub k 0.1. 3 is equal to v. 200 times 4.9 divided by 3 square root 18.0. 18.07, yes. Okay, and that's the Atwood's machine. Okay, next. Problem 2. Problem 2 is similar to the conservation of energy and momentum from the lab. I want to know what this final velocity is, so we have to work kind of backwards. The first part is, you know that it drops a certain height h. This is length L, this is length L minus h, and that is, oh, I was doing bad things. Probably what I did I didn't give him the theta because that was just a typo. Let's just say 30. Cosine theta L minus H over L. L cosine theta is equal to L minus H. So H is L minus L cosine theta. And that is the H. Now it's an inelastic collision. They both combine. This is to go from there to there, you do conserve energy. So the energy at the top is the energy at the bottom. The energy at the top is the combined mass GH. And then the energy at the bottom is entirely kinetic energy, 1/2 m prime v squared. So those m's cancel. I'm looking for v. So v squared is 2gh. V is the square root of 2gh. So that velocity is the square root of 2g L minus L cosine theta. And you could factor out the L if you want. That is the velocity after impact. I'm only interested in the velocity of the object before impact. That's an inelastic collision. Momentum before is equal to momentum after. M1 plus M2 V, and then this is M1 V1. So V1 is equal to M1 plus M2 V M1. And that is the equation. So solving it out in algebraically. And what was really, just as a side lesson, the students really who benefited from using algebraic notation is when they wrote down the Atwood string problem for the whole version. They did it algebraically, and the equation is the equation. It doesn't matter what numbers you put in. And so even though one of the numbers would produce a scary result, the graders knew what you were doing and gave you full credit just by producing that one equation. So whatever this produces, 1 plus 5 over 1 square root 2 times 10 times 0.4, 1 minus cosine 30 degrees. Yeah, I'm going to put, yeah. So it's 6 times square root. Did you get an answer? 6.2? Yeah, hold on. Ooh. 6.2, confirmed. Okay. What I'm going to do is one more problem, and then we'll finish off the test on Thursday. But we won't do multiple choice, and we won't hand out tests, so we'll have a lot of time. Also, pay attention to the videos in the afternoon because effectively we're going to be going through all these finals. So you'll be seeing a lot of problems. The final in the afternoon will not be different other than the explanation of what the final's like and stuff. Problem 3. A is 3 meters at 90 degrees. That should immediately change to 3y hat. B, 4 meters at 210. That is a third quadrant. I'm looking for basically the resultant only. 210 is a third quadrant. That's 210. To get that angle, 210 minus 180, or 30 degrees. Bx magnitude, By magnitude. Bx magnitude is B cosine theta r. By is B sine theta r. 4 cosine 30, 4 sine 30. Sine of 30 is 1/2, so that's 2. 4 cosine 30, 3.46. So the A is 3y hat only. The B vector is negative 3.46 and negative 2. So our C vector in component, negative 3.46 x hat plus 1, or just 1 y hat. And include your units, meters. So that's the resultant in component notation. Now we got to put this whole thing back together. It's a second quadrant, magnitude 3.46, magnitude 1. That is the reference angle. The absolute angle is 180 minus the reference. C as a magnitude is Pythagorean, 3.46 squared plus 1 squared. Square root of 13, 3.6. Reference angle, inverse tan of magnitudes of CY over CX. So this is the inverse tan of CY, 1 over CX. 3.46. Remember, magnitudes only. And I get 16.1 degrees. So C as a 163.9. So C vector as a polar, 3.6 meters at 163.9 degrees. And that's it. So this was a brutally done, or brutally fast way of doing this. As I've said before, we will begin with problem 4 of the May final on Thursday, and then continue on with the problems of another final. Multiple choice will be done outside of class from now on, and then we've got the tutorial Friday, 1 o'clock.
What version did you say this was?
Huh?
What version did you say?
This version was
It's labeled on Blackboard as the one we
I'll mark it up online. I'll put it up online.
For the WASA test, do we add that to